Today we take up the chapter on integration. It is a part of calculus. As a layman understands, integration is the inverse operation of differentiation. Integration, see particularly calculus, two people were responsible for the development of calculus in the same continent, in England and in Germany, one by Newton here in England and Leibniz in France. They developed the same calculus, but in Newton proceeded from one side and the inverse operation, that is integration, is used by Leibniz first and then he developed differentiation. That means what? Both the people in the same continent, two people developed the calculus in different ways and one say ended with integration, Leibniz ended with differentiation. So Leibniz is responsible for the development of integration. The integration symbol is due to Leibniz. That one should remember. The integration symbol, summation of finite number of series can be found out by arithmetic progression or say geometric progression or binomial expansion, binomial series. But infinite series, geometrical series containing an infinite number of terms or exponential function also can be used, logarithmic function can be used. Summation of terms is written as Sn. Sn means what? Sum to n terms. S is written means what? In general, S suffix infinity is written as sum to infinite number of terms. Summation of infinite number of terms can also be written as S. The word S or the letter S can be elongated and that is the integral sign of integral sign. So now we take up integration. In that I take if definition I give it as a layman understands. If d by dx of gx is equal to fx, then integral fx dvx is defined as gx. Now since d by dx of gx plus c, where c is a constant, is also equal to fx, then integral fx dx can be written as gx plus c by definition, above definition, where c is a constant. Somebody can put c is equal to 10, here the answer is 10. Somebody writes here 15, here 15. So like that, c can be any number, so c cannot be affixed with any particular number, therefore it is indefinite constant. So therefore, these are, first of all, we take up indefinite integrals. That is, integral fx dx is equal to gx plus c, where c is a constant. According to one person's, according to a particular problem, c may be 10, another problem, c may be minus 1 or 0 or something like that. So c is indefinite, therefore we take now indefinite integrals. Chapter on integration. Indefinite integrals and definite integrals are two chapters. So we take up today indefinite integrals. Now, say for every formula that you find in differentiation, there is a corresponding formula in integration also. Now, for example, we shall derive one formula and the rest of them by the memory of formula in differentiation, we can write the formula in integration also. First formula, since d by dx of x power n plus 1 by n plus 1 plus c is equal to n plus 1 is already there and we are in the denominator, and in the numerator x power n plus 1 by the formula n plus 1 into x power n plus 1 minus 1 and denominator is already there, that is n plus 1 plus 0. This n plus 1 cancels, this 1 and minus 1 also cancels, this is equal to x power n. Therefore, integral x power n dx is equal to x power n plus 1 by n plus 1 plus c, where n not equal to minus 1. Because if n is equal to minus 1, something divided by 0 is infinity, we cannot use infinity in equality sign. In the same manner, since we have got differentiation of log x is what? 1 by x. Integration of 1 by x. Whenever integral sign is there, dx should always be written with respect to what we are integrating, that is what dx. Log x plus c, because differentiation of log x is 1 by x, differentiation of c is 0. In the same manner, the rest of the formulae, for every formula in differentiation, there is a corresponding formula in integration. Now we have got third one, integral dx by root x. Now differentiation of root x is what? 1 by 2 root x. So here dx by not 2 root x but root x is there. This 2 you can put here. That is 2 root x plus c. Why? When you differentiate this root x, 1 by 2 root x, 2 cancels. You get 1 by root x. This is 0. C, differentiation of c is 0. Therefore, integration of 1 by x is what? 2 root x plus c. Number 4, integral e power x dx. Differentiation of e power x is e power x only. Therefore, integration of e power x is e power x plus indefinite constant c. Integral sin x dx. Integral sin x dx is equal to differentiation of cos x is minus sin x. So only sin x means what? That minus sign you can put here. Minus cos x plus c. Because if you differentiate cos x, you get minus sin x. Minus into minus becomes plus. So integration of sin x is what? Cos x. Integral cos x dx. If you differentiate something, you get cos x. What is that? Sin x. So integration of cos x dx is what? Sin x. Number 7, integral secant squared x dx. If you differentiate something, you get secant squared x. That is nothing but tan x plus c. Here also plus c is required as we are doing indefinite integrals. The 8th formula, similarly, cosecant squared x dx. This is nothing but differentiate cot x, you get minus cosecant squared x. So differentiation of minus cot x is plus cosecant squared x. So write minus cot x plus c. Number 9, you can say integration of secant x into tan x. It is directly, you can write it into dx. If you differentiate secant x, you get secant x tan x. So therefore, the answer is secant x plus c. And the formula are here. By the side I am writing number 10. Integral cosecant x into cot x into dx. Differentiation of minus cosecant x is plus cosecant x cot x, because differentiation of cosecant x is minus cosecant x cot x. That minus sign you can put here, minus cosecant x plus c. Number 11, you can say integral a power x dx. If you differentiate a power x into log a, you get it. Here by log a is not there, therefore you can supply here a power x by log a plus c. If no base is written, base is what? E. So if you differentiate a power x you come across a power x log a cancels, you get only a power x. Number 12, if you differentiate sin inverse x, you get root of 1 by root of 1 minus x squared. So this can be written as dx by root of 1 minus x squared is equal to sin inverse x plus c. And 13th formula is what? Integral dx by 1 plus x squared. You put the question to yourself, if you differentiate something, you get 1 by 1 plus x squared, that is nothing but tan inverse x. Tan inverse x. You see, as a note, you must remember, uh, integration of a sum is equal to sum of the integrations. So, integration of fx plus gx with respect to x is what? Fx. Integration of fx plus integration of gx plus c. Now, you may feel that we are making two integrations, so therefore there should be two constants. Suppose if the constant for this one, first integral is what? C1, second integral is what? C2, then C1 plus C2 is another constant, that is C. So remember this while working out problems. Now we shall take up some examples. We develop from simple examples to complicated things, one after another. Say first one, integral x power 10 into dx. Now remembering this one, directly if you differentiate something, you get x power 10 like that. Instead of that, we can reuse the first formula, that is what? X power, this 10 plus 1 by 10 plus 1 plus c. 10 plus 1 easily you can make out, that is what? X power 11 by 11 plus c. If you want to see whether you are correct or not, differentiate the right hand side. You will get 10, 11 into x power 11 minus 1, that is what? X power 10. And here denominator 11 minus 1 is what? 10. And when differentiating 10 here, so 10 and 10 cancel, you get x power 10 only. So next problem, second one. Here I have taken integral power in the numerator. Suppose integral power, the power of integral power of x is what? In the denominator, x power 7. Directly there is no formula, so by laws of indices, this can be written as x power minus 7 into dx. This can be written as x power minus 7 plus 1 by minus 7 plus 1 plus c. It is x power minus 6 by minus 6 plus c. This also can be written, if you can write, fine. If you can't write, if you need not write also. This is minus 1 by 6 x power 6 plus c. Now we take a fractional power in the numerator. So integral x power 1 by 3 into dx. After all, that power is nothing but n according to the first formula. So x power 1 by 3 plus 1 by 1 by 3 plus 1 plus c. Why? X power n is there, x power n plus 1 by n plus 1. N is what? 1 by 3. 1 by 3 plus 1 by 1 by 3 plus 1. So that can be added by simple this one, x power 4 by 3 by 4 by 3 plus c. Now this also can be done, this denominator, the denominator goes to the numerator. That is 3 by 4 into x power 4 by 3 plus c. You can write. Number 4 can be written as integral dx by integral fractional power in the denominator, cube root of x squared. A lot of indices also are required here. This can be written as by indices. Denominator is what? X power 2 by 3. It comes to the numerator, x power minus 2 by 3 into dx. Now n is what? Minus 2 by 3. So you can write x power minus 2 by 3 plus 1 by minus 2 by 3 plus 1 plus c. This can be written as x power 1 by 3 by 1 by 3 plus c, or 3 into x power 1 by 3 plus c should be written. Now we take the fifth problem. Integral root x dx. See, root x is nothing but x power half. So integral x power half into dx, it is nothing but x power n. N is what? Half. X power half plus 1 by half plus 1 plus c. It is equal to half plus 1 is 3 by 2. So x power 3 by 2 by 3 by 2 plus c, or this 3 by 2 in the denominator can be written as 2 by 3. Because denominator of the denominator goes to the numerator. X power 3 by 2 plus c. Next, we will go to this sixth problem. Say trigonometric expressions we take. Integral, we cover all the formulae in one problem, or two problems. Integral cos x minus sin x plus secant x plus into tan x into dx. You can write, there is nothing called steps here. Integration of cos x is what? Sin x minus integration of sin x is minus cos x. Integration of secant x into tan x is what? Secant x plus secant x plus c, or the same thing is written as sin x plus cos x plus secant x plus c. Now, seventh problem. Say sometimes the coefficients will also be there, constant coefficients. They need not be integrated, constant can be taken out. So, integral 2 secant squared x minus 3 cosecant x into cot x into dx. So, you can see this is what secant squared x, not sin squared x, secant squared x. So this is equal to 2, you keep like that. Integration of secant squared x is what? Tan x minus cosecant x cot x integration is what? Minus cosecant x. And then indefinite constant c we add. This is nothing but 2 tan x plus minus into minus is what? Plus cosecant x plus c. Now we take eighth problem. Integral 3x squared minus 2x plus 5 into dx. 3 you keep like that. Integration of x squared. Now you know that x power 2 plus 1 is what? 3 by 3 minus 2 into x. X means what? X power 1. So x power 1 plus 1 is what? X squared divided by 1 plus 1 is what? 2 plus 5 into 1 you get it. Integration of 1 is what? X. Because differentiation of x with respect to x is 1. So 5x plus c. Here 2 cancels, 3 cancels. And the step is written as x cubed minus x squared plus 5x plus c. Now we take ninth problem. Integral root x minus 1 by root x into dx. Here root x cannot be integrated, but it should be written by indices. Integral x power half minus 1 by root x, I keep like that. We can write it as x power minus half here, but we have got a ready-made formula 1 by root x whose integration can easily be written. You have got a formula. So this is equal to x power half plus 1 is what? 3 by 2 by 3 by 2 minus 1 by root x integration is what? 2 root x plus c. This can be written as this 2 goes to the numerator. 2 divided by 3 into x power 3 by 2 minus 2 root of x plus c. Now we take up the 10th problem. Integral 2x squared minus 3x plus 7 whole divided by root x into dx. Directly, this is just there is a numerator as well as denominator is there, so we cannot work out directly. So term by term we divide integral to here x square by root x is what? Root x means what? X power half, 2 minus half. X power 3 by 2 minus 3 into x by root x. X is what? Root x into root x. One root x cancels. You get x power half. One root x remains. Plus 7 by root x into dx. Now this can be written as 2 into x power 3 by 2. 3 by 2 plus 1 is what? 5 by 2. X power 5 by 2 by 5 by 2 minus 3 into x power half. Half plus 1 by half plus 1. That is what? X power half plus 1 is 3 by 2 by 3 by 2 and plus 7 into 1 by root x. 1 by root x integration is what? 2 root x. 2 root x plus c. Now there is no multiplication. Here 3 cancels. This denominator goes to the numerator and that is nothing but 4 by 5 x power 5 by 2 minus 2 into x power 3 by 2 plus 14 root x plus c.